Okay, so now I wanted to go over a few things where we have a few exceptions where things don't work out quite as nicely as we had hoped. So I asked you to solve these two problems, and you may have come up with what I came up with. After I replaced my x value, I found that here's my x, it's isolated, so I'm going to take whatever x is equal to, negative 3y plus 7, and I'm going to put it in place of that x right there. And that's what I did down here. I put in place of that x negative 3y plus 7. I used the distributive property. I ended up with negative 6y plus 14 plus 6y equals 14. And I ended up with actually 0 equals 0 or 14 equals 14 when I combined my like terms. I'm not sure why my pen stopped working, but we'll see if we can get it to work now. Okay, so if I had just combined like terms, negative 6y plus 6y, that would have given me 0 plus 14, and I ended up with 14 equals 14. Same thing over here. I could have, when I did this one, and I replaced my y, here I had a y by itself, so I put 3x plus 2 in place of the y right there. And when I did my distributive property, I ended up with 6x minus 4 equals negative 4. And when I combined 6x minus 6x, I ended up with negative 4 equals negative 4. Or I could have had 0, added 4 to both sides, and I would have had 0 equals 0. Either way, I lost my variable. My variable disappeared. And what do I do when my variable disappears? Because remember, my goal was to find the point, x and y, that these two equations had in common, but suddenly my method has eliminated my variable. So when that happens, when you lose a variable, you have two possible options. You have one, that these two lines are the same line, and therefore every point on the line, every point is a possible solution. So there are infinite number of solutions. Or these two lines are parallel, and therefore there are no points. So how do you know which is which? When your variable disappears and you end up with a true statement like 14 equals 14, or negative 4 equals negative 4, or 0 equals 0, then we know that it's the same line and there are infinite number of solutions. Okay, so these two lines are really the same line, and these two equations are also really the same equation. We could simplify them. We could actually see that they're the same equation. And so therefore, the solution is infinity, or the infinite. There's infinite solutions. Let me show you an example of when we have two parallel lines. And those parallel lines, what happens when we try to use substitution? So over here, I have x equals negative 3y plus 7 and x equals negative 3y plus 5. Well, I have my isolated variable, so I'm just going to put whatever these x's are equal to. I'm going to put them opposite on either side. So I have if the first x is negative 3y plus 7, that's equal to the second x, which is negative 3y plus 5. And I'm going to go ahead and move my variables, my y's, over to one side. So I'm going to add 3y to both sides. And what happens? Well, my variable disappears, and I end up with 0 plus 7 equals 5, or 7 equals 5. So 7 equals 5 does not make sense. That is not a true statement. And so when it's not a true statement like that, and my variable has disappeared, then that means I have parallel lines. My lines are parallel, and I can say that there is no solution. And we could see that if we looked carefully at our lines. Now this happens to be x equals negative 3y plus 7. So if I wanted to put it in slope-intercept form, it would look like this. 3y equals negative x plus 7. And the other one would be 3y equals negative x plus 5. I'd have to divide by 3 on both of them, so eventually I would end up with a slope of y equals negative 1/3 x plus 7, and y equals negative 1/3 x plus 5. Notice that the slopes are the same on the line. The only thing that's different is the y-intercept. So these lines have a parallel slope, which means that, or have the same slope, so the lines are parallel. They're just one is shifted up higher than the other. It starts at 7, where the other one starts at 5. They're parallel lines. If I had put these both in slope-intercept form and compared them, and they both had the same slope and the same y-intercept, then I would know that they are the same line. So again, remember that lines can either have, or systems of equations can either have one solution where you have two lines that intersect and we have one point. And that's easy. You solve for x, you solve for y, you find out what the x and y are. If you lose your variables and then it doesn't make sense, you come up with a crazy solution like 7 equals 5 or 0 equals 8, you know that there is no solution. There's no solution, and that's because the lines are parallel. And then the third type of system of equations is when the line is the same. The two lines are the same line, and then that means that you have an infinite number of solutions. All right, last thing. Up here are all the steps in how to solve systems of equations using substitution. And now all that you have to do is write yourself a key idea, an important idea that you want to remember when you're solving systems of equations right there at the bottom of your page. And I'll see you in class.